So many things happening today. I hope you're having a good second day of the conference. My name is Jason Brown. If you don't know who I am, I'm currently board president of MSA. It's my honor and privilege to be introducing our featured speakers for this panel on engineering with two members from Rbhu, which is an engineering company that specializes in large-scale artwork and entertainment structures. Rbhu is inspired by two former schoolmates who dreamed about engineering things with purpose, things that provide joy for people and things that can change the world. Their dream became a reality when they joined teams and began to work with artists who have touched the lives of hundreds of thousands of people through their work and inspiration. Rbhu now aims at working closely with their clients and providing affordable services to artists and those who have a vision. Rbhu is a Sanskrit word meaning builder, artist, prudent, skillful, and clever. Ali Lahijanian is a co-founder, and Ali received his BS and MS from UC Berkeley in mechanical engineering. Due to his passion for Earth and humanity, after graduating, he spent several years at an offshore wind turbine company in an effort to reduce humankind's carbon footprint. Ali strongly believes that art and new ideas expand the capacity of the human mind, and that the exposure to artistic innovation is necessary for the betterment of the world. For these reasons, he is honored to bring his talents and experience to engineering imagination at Rbhu. I'm just reading off of their website, so if you guys want to check out the website, it's pretty awesome. We'll put the link for that in the chat as well. Selinda Martinez, who is also a co-founder of Rbhu, will not be joining us live today, but has a pre-recorded presentation, correct? Selinda received her BS from Cal Poly, San Luis Obispo in architectural engineering. She has dedicated over 10 years of her career to engineering structures. Selinda became particularly captivated by the community of artists, builders, and engineers who come together to bring large-scale concepts to life and the collective opportunity to create positive impact on a macro scale. Selinda is committed not only to supporting the proliferation of art on a global scale, but also to convening and fostering a collective of artists and makers whose cooperative efforts bring artistic imagination to life. I'm sure that Ali will talk about this and Eleanor in just a minute, but if you hadn't noticed in the past couple months, Rbhu sponsored some pretty amazing grants for artists to get some pro bono engineering services. So you should keep following their social media. They're really doing a lot of extra and unusual, generous work in support of sculpture and artists. Finally, I have the pleasure of introducing Eleanor Reynolds, who's here with us in person, attending the conference. Eleanor received her BS and MS from the University of Texas in Austin in architectural and structural engineering. She spent the last decade designing building structures all over the world and is thrilled to be joining the Rbhu team. I guess this is probably.
I'm the newest and also one of the oldest.
Oh, okay. Well, you've joined the team now, and I'm sure you're still thrilled, right?
Yeah.
Okay. Eleanor believes in the power of art to bring people together and open new avenues of communication. Her favorite thing about being a structural engineer is collaborating with artists and architects to bring people's wildest dreams to fruition. It's the balancing act between art and physics. And with that, I will turn this over to Eleanor and Ali. Thank you so much.
Thank you for that introduction. And I guess I just want to say I am so appreciative for being able to be with you all and you all. Ooh, are you guys getting feedback? No. Okay. And with you all virtually as well, it's been really inspiring to be a part and participate and listen to all of the presentations and conversations. I found it truly inspiring. So thank you for that. My name's Eleanor. If we haven't met, I would love to meet you all. And this is Ali.
Hi, everyone. This is Ali. I can't see you, but I'm sure I would love to see you next year in person. And it's a pleasure. And thanks for the warm introduction. And we're looking forward to this presentation.
Up here.
There you go. Yes. Okay.
So we're going to go a little meta on me for anyone who's on Zoom. So we're going to talk a little bit about some of the engineering that goes into taking the vision of the artist and the maker, the designer, whatnot, and translating that into the physical world that we live in, and sort of some of the challenges and the processes that go along with that. As an overview of what we're going to talk about, see if I can find my mouse. Here it is. I'm going to give you a little background about Rbhu, who we are as an organization. I need to stay on camera. Who we are as an organization and what we're about. And then we'll talk a little bit about the process. If you've never gone through the process of working with an engineer and going through that, we'll sort of break down what we're doing and what the artist is doing in that process. Then we'll talk a little bit about some effective communication strategies with your engineer. Not all engineers are super familiar of working with artists. So we'll give you some kind of thoughts about that. And then we'll touch on some of the benefits that working with a licensed engineer can bring to your large scale sculptural visions. So a little background about Rbhu. We are an engineering firm. That's how we identify. We're all engineers, but we have a lot of varied backgrounds. So there's mechanical engineers, civil engineers, architectural engineers, structural engineers. And so we have a lot of different experiences and backgrounds that have brought those of us together. There's usually about 6, but that can expand at certain times of year. Any comments on sound? How is it on Zoom? Great. So our first sculpture, which we're going to talk a little bit about in a minute, was done by Selinda was done in 2010. And then that sort of germinated. And then in 2014, Ali, who's my co-presenter, and Selinda formally created Rbhu. And since then, we've done about 150 different sculptures. There's a lot of variety in that and a lot of different kinds of materials that we'll work with, structural glass and concrete, steel, aluminum. So we're down to work in pretty much any material out there that we can get permitted. And then also, big pieces, huge buildings and sculptures, down to smaller things that may just need like some foundation consulting. We really want to make sure we're there to enable the artists to get their vision installed and out in the public space. We've been really honored to do some that have gotten a lot of press. We're sort of in the background on those, but it's been really an honor to be a part of some pieces that have gotten a lot of recognition. So that's been really wonderful. And our work, we do primarily work with artists and fabricators. The relationship between the artist, the engineer, and the fabricator is so important if you're gonna get something built and installed in the public. And so our day-to-day is very closely connected to the fabricating team, whether that's in the artist studio or whether they're bringing on another team for that. And we work with the city officials a lot. If you've gone through the process of public art, you will know that that can be wonderful and it can be painful, but we are very familiar with the process. We work with cities all over the states. We're permitted in probably more than 20 states at this point, and we're always game to get new licenses. And then also with event producers, we do a lot of work with various event producers. This is our origin story. This is Bliss Dance. She is a sculpture that was done by Selinda. She was that seed, and I'm going to get her to talk about it actually.
Hello, MSAers. I'm Selinda Martinez. I'm one of the co-founders of Rbhu Engineering. Wishing you a very warm welcome from Portugal, and also here to tell you a little bit about Bliss Dance, the very first sculpture we engineered in 2010. I was a senior at Cal Poly in San Luis Obispo, California, and this was my senior project. So it was the very first thing I ever engineered. And she is a 40-foot tall sculpture of a woman dancing on 1 foot. So no small engineering feat for a new engineer. But she's the catalyst for the birth of Rbhu and why we're all here today. So very thankful for that. Structurally, she is a steel space frame within, and then she has a secondary space frame that makes the contours of her body and then is sheathed with a metal mesh. And you can imagine that at the base of her foot, there's a lot of forces going through that. So believe it or not, in that small footprint, we have 6 2.5-inch diameter solid steel bars that are supporting all the loads. She was debuted at Burning Man in 2010, was on Treasure Island in the Bay Area of California for 5 years. After Treasure Island, she was purchased by the MGM Grand Hotel in Las Vegas, and now she sits there permanently at the park on the Strip. So something that we're very proud of, even still today, one of the pieces that just makes me the most proud. So I'll kick it back over to Eleanor. Thank you. I hope you enjoy the rest of your conference.
So as Selinda mentioned, we've been really fortunate and honored to continue to be a part of Black Rock City and what they build out in the deserts of Nevada in the summers. Hasn't happened for the last 2 years, but before that, for the 3 years prior, we engineered their man sculpture. So if you don't know about Burning Man or Black Rock City, which is the installation of Burning Man in Nevada, it's a 7-day festival. About 70,000 people go out and live together, create a community in the desert. And what's really exciting for us about that is it is probably, if not the largest gallery of large-scale art that's done in the world. In 2019, the last year that it happened, that Black Rock City happened, there were over 400 sculptures that were installed in the desert for that week. And so it's a huge undertaking, and there are lots of engineers and fabricators and planners involved in that. And we've been really honored by Black Rock City to be a part of their man and their temples. One of the fun challenges, and why I'm showing the man, and I'll show you some temples as well, is a pretty unique condition out in the desert. We have pretty intense windstorms out there that can kick up a lot of dust. And then we also have a very unpredictable level of human interaction with these sculptures. So we really aren't totally sure how the community is going to want to interact, and there's not a lot of rules. So we are very thoughtful about the way these pieces come together and the way people might want to explore these sculptures, which is incredible, but we want to make sure they're safe. So they're these very sturdy sculptures that can take a lot of beating, but also they need to collapse and burn quite quickly. And they need to collapse inwards on themselves so that they come down safely and they burn uniformly. And so we're working with the artists and the designers to make sure that as we think about how we're going to put it together, we can build it in a couple of weeks, and that it will collapse down on itself in a very safe and quick and beautiful way, because that's a big part of the experience of the temples and the man. The other realm we work in a lot is the public art sector. That has a lot to do with the fact that jurisdictions will often require, if not always require, their artists to engage with a licensed local engineer. And this has to do with, public safety and bureaucracy and all that sort of thing. But we really see ourselves as a way to enable artists and come alongside artists to help them get through the process and achieve their vision, and help them connect with fabricators. Because sometimes we're working with artists who don't really know, we have this great vision and they've been selected by a jurisdiction or a committee like GSA, but we want to help make sure that they get the right team involved to get their installation. These are a couple of projects that just show like a wide range of sizes and scales. They're all over the states. I I don't know that we have time to talk about each and every one, but I'd be happy to, or Ali, you can ping us, email us, whatever. You can check out our website. We have a lot of examples of our work up there as well. And by our work, I mean our collaborations. We are always working with an artist. And the last thing I do want to talk to you a little bit about before we get into the engineering process is something that that we touched on a little bit. It's the giving campaign we do annually now. The idea for Rbhu Gives Back started in 2019. We had done pro bono projects before, but we were involved in this project on the top right of your screen, the coyote. And an artist came to us and said that they had this vision for this project. They didn't have a big budget, but they were really excited about providing a sculpture that would provide information and resources to people as they came in seeking asylum into the States. And we got really jazzed about that. We thought it was a really worthy goal and we wanted to be a part of it. And so we decided, let's do it. Let's get them through permit. Let's just do this as a pro bono thing because this is an important project and something we think needs to be placed. So we did it, we went through, we got it installed in Los Angeles and we're really excited about this piece. But that then sparked sort of some internal conversations of, you know, this was really great. Let's do this intentionally. Let's do this regularly. Let's not just kind of take one-off projects when someone is bold enough to come to us and say, please, can you help? Let's say, hey, come to us. We want to help. So we started the giving campaign, Rbhu Gives Back, in 2020. That was the official launch. And we gave out 7 grants for pro bono engineering services. Most of the projects that are up on the screen are part of that campaign and have been taken to either installation or, you know, a pricing exercise so that more funding can be, you know, gathered in order to install them. We just had our 2021 campaign. I think it closed a couple months ago. We were asking for proposals and we're in the process of reviewing those and talking to the artists, and we'll be selecting grantees for this year. But we are, as a team, really committed to this campaign. It's something we want to continue to do annually. So I'm sort of plugging it next year, in years to come. If you get in a place where you have something that is, you know, part of a mission, part of a community, grassroots, you know, something you're passionate about basically, and you need some support, keep us in mind because we are regularly going to be out there and asking for people to let us know how we can support artists with or without proper, you know, funding from GSA or some municipality and arts district. I'm going to turn it over to Ali.
All right. Well, I'm going to talk about the engineering process, the most interesting part of this. I'll try to make it as fun as possible. So there are 6 steps that I'm going to go through from the beginning to the end, what the beginning looks like, towards the end, what the end product looks like from the engineering perspective. So first, what we need is an idea. We need your idea to be able to understand the sizes, the height, the width, and all the parameters that are needed for the engineering. So the best way to do that is for, first of all, we want your idea to be dialed in perfectly before you hand it to us as engineers, because when we start the work, we are pretty much assuming the vision is dialed in and the aesthetic is how you want it. So for you to be able to do that is to bring your vision, this is a suggestion, to bring your vision into a virtual world, to a 3D model, to be able to understand the ratios, the aesthetics, and in the virtual world, obviously it's a lot cheaper to change things and update and, you know, make any changes aesthetically you need. And there are a lot of free programs out there like SketchUp, Inventor, I think for students is free, and AutoCAD, but there are also a lot of free 3D modeling programs that if you search online, you could find. We highly recommend doing that because, as I said, it's a lot more economical to change things in the virtual world. And after you do make a 3D model, we suggest, so also going to the 3D model aspect is that it really helps with the mechanical systems to be able to dial in your mechanical component. So this, for example, is Noetica that was debuted in 2017. We came up with this very complex bearing system that had to have 6 degrees, 3 degrees of freedom, and there are cubes that are moving in space. When we 3D modeled it, we realized there are clashes within the cubes, and we realized that this system is not working as well as we thought it would. So we went back on the drawing board and we came up with this really simple system. It's just a ball joint with wires coming up, and we modeled it and it worked perfectly. So we were really happy. Then we proved the concept through a 3D world and virtual world. And that was a lot more economical than actually prototyping. So after you bring your vision to the 3D world and figure out your aesthetics and iron out all the kinks, we recommend doing a scale model. So this is Eelgrass, that is now Eelgrass project that we did. It's in Richmond, ferry building. So the artist, you can see on the left, he sketched it, then he made the scale model. So we highly recommend, after doing the 3D model, doing a scale model in the mini scale or full scale out of a different material to dial in again the aesthetic. It's very important for you to hand in a product that you think you're happy with visually to an engineer. There are other ways that you could make a scale model is you could 3D print with today's technology, everything is easier than what it was before. You could take your 3D model and just print it. And in the physical world, you can see it and you can see the ratios and aesthetically to make changes that you need. So next slide. So after you dial in your aesthetic vision and you know that this is the vision, this is what I like, this is what I want, you want to hand it to us. And the reason we say that is that, for example, in the middle of engineering, you say, oh, I don't know if I like this ratio. I want to make it smaller. I want to make it bigger. Those changes have huge impact, or it could have. Maybe some of the changes they won't, but there's a potential. But some changes have huge impact on the engineering, and we might have to start from scratch. So after you do the 3D model, so I'm going to show you this example of the flamingo. Also, this is a very controversial piece. People think that we made the piece to have 4 legs. No, the artist wanted the piece to have 4 legs. So I just wanted to put it out there before I talk about it. So he made a 3D model. He figured out all the dimensions, the heights and everything. And then he made a scale model, and then he handed it to us. From there, we created the structural engineering model that you can see on the right, and it's showcased by the lines, but all the lines have properties, and I'm going to go through it on the next slide a little bit more. So we start with the global analysis. What is global analysis? Meaning that we're going to size the tubes, the pipes, and the plates and the I-beams. All that is the global analysis. So we take the model, we put the wind load. In this case, there were also humans that going up the ladder and going at the top. So we put the live load. These are all the loads that the structure will experience. Then we do the analysis. There are 2 types of analysis. One is static, meaning that it doesn't move. Another one is dynamic. And within the static or dynamic, there are 2 types. One is frame. Another one is shell. Shell meaning that is made out of plates. So frames, this is an example of the frame that are all, frames are like square tubes, pipes, I-beams, are well-defined components or members. And shell analysis is made out of plates. So for example, in the temple that Eleanor showed earlier, this example, the crown at the top is made out of plywood. So it's a little bit more complex engineering. and it's a different analysis, but it's very well possible. So you can see in this video, the wind is hitting it in different direction. You can see the movement. Also, so you know, this is exaggerated by like 40 times. With the naked eye, you won't see that much displacement. So it's not that scary, but we do our analysis so we understand the movement, the motion, the load path, and all that.
And then stress.
And the stress. So the next slide, we're going to talk about, this is actually the first piece that this first sculpture that I engineered, Peter Hodson. He was in Marco Cochrane's shop, so he needed a mechanical engineer. I joined his team. This is a scopotropic zoetrope. It's 24 feet tall. They're casted human going up the ladder and doing a backflip. The frame per second of the video doesn't match, so you can't really get the full effect because the strobes are not matching the frame per second, but you kind of get the idea. So this is a dynamic, the top portion moves, and these figures, it looks like they're going up the ladder and doing a backflip. For this one, this is a dynamic analysis. And the dynamic analysis, as I mentioned, they're frames. So you can see these are the Schedule 40 4-inch tubes. And the red parts that you see are hotspots, meaning that they're seeing the most amount of stress. In this case, they're not failing. They're still way below the allowable, but you can see where the critical part of the structure are that we need to pay more attention to. On the next slide, you can see the plate analysis. So this is the shell analysis. As I mentioned, it's a little bit more complicated because you have to discretize it, but that's the type of analysis we have to do. And then you can see everything is blue except that top part is turning. You see the stresses are mainly over there, but again, they're below the allowable. So that all worked out. So after we finish our analysis, we come up with the member sizes, and we provide the global member sizes, meaning that the sizes of your tube, again, the plate thicknesses and such. So this is on the left, the frame analysis, the static, and you can see on the red parts in this case are failures. So we went back to the artist when we told them, okay, here are the parts that are failing. And on what you can see, we modified it and we optimized it. There are a lot less frames actually in the middle one than the left one, because we understood the load path, we understood where are the critical parts, how we should go about this such that it's structurally sound. So we achieved that. And at the end, we came up with the sizes. The legs were 6-inch square tubes, 1/4 inch thick, and the body was 2-inch square tube, 1/8 of an inch thick. So after we come up with that, also that's where we also know the loads for the anchors. And sometimes for city projects, for example, they want to put a foundation yesterday. So this is the point that we are like, okay, now we can design the foundation. Now we can design the anchorage and base plates. So they can do their thing while we finalize all the little details and nuts and bolts, which I'm going to show you on the next slide. We do the detail analysis. Detail analysis meaning that all the connections that are happening, nuts and bolts. So in this case, there were 2 attachments that were happening. The neck was separated from the body, so we needed to design a bolted connection there. And also the legs were all coming off and needed to be attached. And so we do that after global analysis, we know what forces are going to each of those nodes or those points that you're seeing. And then we take that and we do the analysis. From that on, we should have all the sizes of the plates, nuts and bolts, all the global analysis. And now it's time for us to communicate with you what these are. So we do structural drawing. With the structural drawing, it's pretty much blueprints of your piece. You know everything that you need to know about the sizes. I want to mention that structural drawings are different than shop drawings because they're not dimensioned for you to cut and build, but they have all the sizes and global dimensions that is needed. And you can see in the base. So in the next slide, you can see the plate, like the bolt distances, exactly what wells you need to use, and what are the details of the, for example, the anchors. This was a Burning Man project, and we used ground screws for those with guy wires. So you can see that on the left, and on the right, you can see the body attachment, how we went about it with 3 bolts. I think there were 5/8 bolts, and you can see edge distances are really important. So there's no tear out and we don't face issues. So that's pretty much what comes out of it. And for permit, also, I must mention that the cities require structural drawing that are stamped. And we have done projects all over the US. And we're looking forward to do more around the world as well. So in addition to the structural drawings, we need a calculation package. So all our analysis, we make a report, we showcase the loads, and we showcase like all the forces, and then it goes along with this drawing that are all stamped, and the city reviews it and issues the permit. And then, so this project, he did all the steps as we talked about, and at the end, it was a very successful project. He got a lot of media attention, even though it was controversial because he was 4-legged, but a lot of people loved it. So Rolling Stone wrote about it, ArtNet, USA Today, and we were honored to be a part of this. The artist's name is Josh Subkoff, and he's an amazing artist, and we have done multiple projects. This was his first project that he did, actually, large scale art. And so we collaborated really closely. And then from then on, he made multiple other sculptures that you may see. One of this, actually, this one that is behind me, Rainbow Bridge, is also Josh Subkoff. So he's a very successful artist now.
So let's talk a little bit about communication with your engineers and your engineering friends, and some sort of strategies. So one of the things about being an engineer is we're working with the laws of physics, right? And so there are some things we can play with, but ultimately we can't control gravity, and we have building codes that require us to design to certain standards, right? And so it's really helpful when we are working with artists to understand what's really important to you. And so understanding your priorities and what your goals are, and so that we can help make sure we steer you in the path that will get you closest to those goals as we can possibly do. But also the flip side of that is to not give up on your vision right away, just because you maybe talk with some engineer who's like scared or unfamiliar or just doesn't really know what to do with something that's not very conventional. Get a second opinion. You can always call any of us at Rbhu, and we can help give a sanity check or a second opinion. And just don't give up right away, because you will find, as you work with engineers, that there will be sometimes pushback when you're trying to do something new and innovative, or just that's not a building, right? Most engineers, we engineer building structures or bridges or something like that. So those would be 2 first things. An example of the prioritization. This was a really cool installation. I'm gonna get Ali to talk about this one a little bit.
Yeah, also on that note that Eleanor was mentioning, our mission is to bring your vision to reality. We are very committed to make sure what you want comes to reality. So that's number 1 important thing to us, to make sure that your vision and laws of physics come together. So just to reiterate what she was saying about shopping around, talking to other engineers, some engineers are not thinking outside the box, or they don't understand the importance of aesthetic as much as we do. So this is an example. There are 3D projected faces on these, you can see on the top heads. It's actually interactive. On the left, you can see those little blue buttons that people come and press, and the faces start singing. So the artist came to us and he had a bunch of criteria. So we told him, like, let's let's prioritize them and let's see what are the most important parts that you want to achieve. So first thing, he definitely wanted it to be 12 feet cantilever, piece. So you can see all those pipes are about 12. The highest one is about 12 feet. He wanted it to pack in a suitcase. So you needed it to be disassembled and be able to, travel around the world, because he wanted to showcase this all around the world. Third piece, he wanted it to be less than 25 pounds, so he doesn't have to pay extra fees for the luggage. The fourth thing, he wanted the piece to not break on 100 miles an hour wind. The fifth one, he didn't want the heads to move more than 2 inches in the 30 miles an hour wind. So when he prioritized it, we were like, okay, we can get 1, 2, 3, and 4. But the fifth one, there's just the laws of physics didn't allow us to do so. But he was happy at the end because he prioritized it. He knew what was the most important thing. And we suggest for you to also do the same thing. See what part of your design that is very, very important to you. And what are the parts that it's okay for you to give up. And again, we make sure to make your vision come to reality as much as the laws of physics allows us to. This piece by Matt Schultz, he took this, so it's called Space Whale. It's a whale that is cantilever, it's 40 feet tall. He went and talked to an engineer who wasn't maybe familiar with the sculptures, or he wasn't thinking outside the box. And he wanted to put support on the back of the whale and support the piece. So Matt Schultz was really angry. He was like, if you put that in there, that ruins the whole piece. I can't, that's not going to work. So he came and talked to us, and we were like, okay, we can figure this out. So we used first of all, we used trusses all over the piece, and we tapered the sizes from the bottom to top. So from the bottom, there were like 2-inch rods, solid rods. And by the time it got to the top, I think it was about 3/4 inch or 1/2 inch rods. So he was very happy at the end. Again, the point is to talk to different engineers. If they say, no, you can't do that, talk to another person to see what they are thinking.
And then a couple other things to just touch on when you're thinking about working with your engineer, whoever that may be. One of the things that's going to be really important to your engineer is where you kind of envision this to be located. Do you want this to travel? Do you want this to be a permanent installation? Where is it going to be? Because the hazards and the kinds of we call them loads, but it's basically like wind force, or an earthquake comes along and shakes your sculpture. That's all very site specific. So if you have some idea of where you want your sculpture to be located, that's sort of a important requirement to understand and to communicate with your engineer, because if it's a temporary sculpture, it's going to have different requirements than a permanent installation. So sort of some idea about where you envision this to be located. This is something you've probably experienced is timelines. A lot of times projects can be very sort of like hurry, wait. Hurry up and wait. And so it's nice to think about deliverables ahead of time, to think about when you need things, when your fabricators might need information from your engineers so that they can order materials. And so thinking about your schedule is actually a really important part about planning one of these large scale installations. And then also something we touched on, there is evolution in the design process, but as you get further along in the design process and you start honing in that design, changes can have pretty large repercussions. So if you need flexibility, it's good to talk about that at the beginning and set up that expectation. So those are sort of some things to think about when you're engaging an engineer, things that are important to them. Us, the eggheads, which I appreciate you including in this conference. And then I'm gonna move this just like right in the way. So some of the benefits, why you might work with an engineer. we, as a licensed engineer, we take an oath to hold public safety paramount. That's what it says. And what it means is our most important thing in our practice is making sure that we are holding the general public safe, and that you learn about all sorts of situations where engineers didn't do that. And public safety is really the first thing we're going to be thinking about when we start engaging with an artist and a sculpture. And how do we make sure that we achieve this and make it beautiful and safe? And so that can give you a lot of peace of mind as an artist who's doing something large, maybe for the first time, maybe for the 100th time. But we're there to make sure that you are confident and that you understand how it's going to work, and that it's safe, so that you don't have to stress about, like, oh my gosh, is this thing going to fall down and like hit a child, or whatever. Also, when you get your engineer involved with your fabricator, you can avoid a lot of unexpected problems, like thinking about installation and transportation and how is it going to be lifted into place, because sometimes you're going to put it on its side and crane it over, and so you want to think about, oh well, like, actually, if it's on its side, I need to make sure I've got attachment points. And so you get your fabricator and engineer thinking about all these steps, and we can help you avoid some unexpected issues during installation or deinstallation or burn down. And then also, we kind of touched on design optimization. We really want to make it the most efficient sculpture that you can. And we don't want you to have to spend a lot of unnecessary money on the bones that might be inside it, unless you want the bones to be really big for some reason. So we were going to be thinking about, how can we make this more efficient? Is there a better way we might put together the insides, unless the insides are expressed, so that it's a really optimized system? And so that can save you a lot of money. I think on some of the projects, the money that we save on design optimization can completely make up the engineer fee. So we're really trying to make this affordable, and we have that in the back of our heads as we're working of what would be the easiest and best and most cost-effective way to provide the bones that your building or your sculpture or whatnot needs. And then lastly, I said by passport. Like I said, different sites have different hazards, but if you get a licensed engineer involved, we can get you a visa at least. Like, you can't just necessarily take a sculpture that's been designed for the woods of Colorado and put it on the tip of Miami, where we've got hurricanes and things like that. But we can help you work with the building officials to make sure that you get that ability to move your sculpture around and place it where you want it to be. So I'm going to open it up for some questions. Hopefully we knew we shouldn't provide any, like math equations or math tests and things like that. But if you have questions for us, it's time to wake back up. And Selinda she's not here today, but that's her email and contact information. Ali and I are here. We are happy to be a resource to you. I have business cards if you want to take one. And that's our website. So go check it out if you want.
I have a geographic question. Just trying to get a sense, because you've got like several people involved in your team. Are you spread out over different places in the world, or are you all in the Bay Area?
So the question, in case you guys couldn't hear it over Zoom, was about sort of the geographic location of the Rbhu team and where we're actually physically located. That is a ever shifting answer, actually. Okay. We work fully remote, and we always have. Pre-pandemic, we were a fully remote team. A lot of us are based in the Bay Area. Pre-pandemic, I was based in the Seattle area, but now I'm fully nomadic, so I am all over. And as you heard from Selinda, she's actually in Portugal for the rest of the year. So we're available, but we're sort of a moving target, and when it comes to our physical location.
Yeah, we don't have a physical office. We've always been remote, and Actually, our three of us, our team, we were just working from Mexico 3 weeks ago. But with today's technology and Zoom, we have no issue communicating. Actually, some of the meetings I have, there are people in the Bay Area that I talk with them over Zoom because then you don't have to travel. You don't have to. It's just a lot more efficient.
Yeah. But like Ali, we usually have at least a couple of people in the Bay Area,
Yeah.
Oakland, Berkeley, Sausalito, things like that. Unless everyone's working in Mexico, that happens.
How large is your staff? How many engineers?
The question was how many staff? We've got 6 people who work pretty consistently and regularly, like on a weekly basis, but that can sometimes grow. During the Burning Man Festival, we have a couple of people who worked with us who've gone on to do other things, but like to come back and help out as in the lead up to Black Rock City. And so, but 6 to 9 engineers. Yes, Mary.
I just want to say thank you, Ali and Eleanor, because you're like a fairy godmother, art angels. To take this on, your generosity is mind blowing. Many, many, many good things are going to come out of your good-heartedness. So thank you from the bottom of my heart. It's amazing.
Thanks.
Thank you.
We have a question.
Do you work with artist conservators to help like artists figure out like a maintenance schedule for their pieces like after you've helped engineer it? Or is that like mostly up to an artist to go out and do afterwards?
The question was about, do we work with art conservators and or artists and the installers to help them determine maintenance schedules? Tell me if I don't need to do this. I guess Zoom people tell me if I don't.
Yeah, we can hear the questions, but it helps for you to repeat it.
So it's complicated. I have worked with art conservators, but usually in the context of this piece hasn't been conserved. Can you help us figure out how to save it and reinstall it? But it is something that has come to my mind while being in this conference. A lot of times we are thinking about finishes, and definitely when it comes to like steel, we're thinking about, okay, is this going to be any elements? How is this being protected to make sure it's going to last? Because Corten steel is really expensive. That's the steel that won't continue to degrade. It kind of rusts and then just stays. Whereas normal steel, it will just literally deteriorate to rust dust. So particularly with steel, we're more thinking preemptively about how do we make sure that this is if it's a permanent installation, that it's going to handle whatever the environment it's in is going to throw at it. But for example, like LED lights and things like that, we would rely on like a fabricator to kind of help set up that schedule of like how often does something need to be necessarily cleaned and things like that. If that makes sense.
And if I add to that, there are some pieces that we would require periodic inspection. So some fatigue oriented, meaning that when it shakes so long, we wanted to make sure that someone goes and checks to see if there are cracks or things like that. And we specify how often that needs to be checked in our drawings. Sometimes we require for example, guy wires or like the steel wires that we use structurally, we don't want them to get loose over time. So we want someone to every few years or every year to go and make sure everything's tight and structurally sound.
I think I saw some examples of this in the slideshow, but I was wondering if you could comment maybe on pieces that maybe you've done that are like immersive walk-in or multiple stories. Is that something that you've worked with?
Yeah. Let's see here. Oh.
Eleanor, also, just so you know, we have a bunch of questions on Zoom as well that we need to.
Oh, okay. Well, Alec, you could kind of talk about some of that. He's worked with some installations that have gone inside of sort of buildings that are being transformed into immersive spaces. And then of course in Black Rock City, there have been, sort of unconventional residences and things like that.
Would you repeat the question? I actually didn't hear that one.
I want to state it right.
Just sort of to comment on works that you've done that are immersive, walk through, multiple story?
Yeah, the question was about to talk about or address some of the immersive pieces. So you've got Baba Yaba's house behind you, actually.
Yeah, so a lot of our pieces, if you mean interactive, we have a lot of so the piece that we showed you, the Eternal Return, the one that people go backflip, I mean not people, the human casted, they do the backflip, is actually human. It has a human drive, so people come and row it and interact with it very closely. We have done immersive pieces. One of the example, I don't know if you saw, it was a head maze. It was a 4-story tall, 40-foot tall, and it was immersive experience, and it was actually modular as well. So it had to be assembled and disassembled. And we work with the artists to know, okay, what are the interactive pieces in there? What are the weights that you're putting in there? What are the, hidden rooms and all that stuff? I don't know if that answered your question properly though.
And really almost anything that's at Black Rock City, not everything, but a lot of it, even if you're not necessarily intending it for human interaction, it does get used that way. For example, the rainbow, people can walk across that. And then the sort of intertwined heart sculpture, you can go up and sit inside that one. And so a lot of what we've worked on, not always in the public art realm, but definitely in Black Rock City, we're thinking about human interaction. And
absolutely, like everything in Burning Man, people can climb it. So we always design for human live load. We should take some questions from the Zoom as well. I think there are a lot of questions now. Could you give a brief overview of cost breakdown and general range? Obviously, that changes project to project. It could be simple as a foundation to a full dynamic analysis. I don't know if electrical is there.
Actually, yeah, and sorry to interrupt us. I think the last question that Jillian asked, I think like you could maybe roll the costs and stuff into that, because I know it's going to be way different, but just if you're like, have no clue, just kind of a broad guideline you would
so
give to someone.
It could be anywhere between $1,000 to like $15,000-$20,000. It just really depends on how complex it is and what's needed from us. If it's just as simple as a foundation, it could be really, or just a letter just reviewing this thing. If it's really small and we don't, so it really varies a lot. It's a huge range. But do contact us and be like, hey, well, what do you guys think? How much the engineering for this would cost? And we're happy to provide an estimate to you.
Well, and that's kind of like what Jillian's asking at the end there, like about funding and how to contact you. So that's very helpful.
Okay, so I'll read that question now. Do artists generally come to your firm with funding that they have already acquired elsewhere? If so, can artists contact you with an idea before applying for funding so they can properly budget for your system? Absolutely. So we would, first of all, I think including engineering your proposal for RFPs and RFQ really helps that they know that you have thought about it and you have contacted, you have an engineer in your team. And yes, we give a range and we provide an estimate, and we're happy to do that before you even submit. And it's a really good idea actually to do that, so you're not surprised by the engineering budget.
Yeah, and I mean, a lot of artists we work with, we understand that they're submitting proposals, right? And you're submitting a lot of proposals, and we want to help them be successful to win those proposals. But we also understand that you can't win all your proposals. So we're happy to come on board and help artists propose something that's buildable and achievable and in the budget, because the budgets can be pretty tight on these art projects, even the ones that are publicly funded. So yeah, we're happy to help, and we understand that, you win some, you lose some, right? That's how it goes.
Yeah, there's another question here. What type of proposals are you most attracted to when it comes to the Rbhu Gives Back? So variety of projects are, first of all, I think I welcome everyone to apply. Second of all, I think the most important thing is that, are you short in your budget for engineering? That's number one important thing.
Oh, I'm going to point out one of our grantees for 2020, they submitted a hand sketch, like a drawing. So it doesn't have to be this big elaborate proposal, if that makes sense.
Yeah, but we do want it to make sure that it would be built, and it's not something that you have that it doesn't come to real life at some point. And some projects that they're not commissioned, we know that their projects are has such a huge potential, which one of our grantees last year actually applied. They weren't commissioned, but we accepted it because we knew that they had the potential to place it.
Yeah, and definitely, mission-driven things, community-focused things, but not just like, oh, so-and-so is going to pay me to put an elephant in the backyard and I want to do, we're kind of looking for people that have a mission or a passion or something that they're trying to give back as well, if that makes sense.
Two questions. What are some of the softwares you use for the analysis parts, and how detailed, like once you have an actual site, how detailed does that analysis get in terms of the wind and sun and all of those conditions? And the second question was, what are some of the most unique or weird materials that you've worked with for the engineering process?
So the question was about software, what software we use and how detailed the analysis gets. And then also what are some of the strangest materials that we've worked with. So software wise, we work, if we're doing a frame analysis, we often work with a program called RISA. It's a structural analysis software. And depending on the complexity of the project, they can get pretty detailed. But sometimes I'm working just like pen and paper and my calculator, like for something that's simple. I'm not going to build some big fancy structural model if I can do a hand calc faster and get you what you need without some big software analysis, if that makes sense. We are pretty specific about sites though, because that's what, if you're going through a permitting process, that's what you're required to have is that address has these specific requirements. And so you have to meet or exceed those requirements. So we are fairly detailed in the permitting process on the site loading conditions. Material wise, I just had my first structural glass project. That was pretty cool. I'd never worked with structural glass before. We have to be, if we're going through permitting, we have to be careful about the elements we're relying on as the structure. We work with some really crazy things that we are cladding structure with, but building departments want to make sure that there's testing data or something that proves that a material has certain capacities. And so
yeah, if I add to that, the piece that you see behind me is the actual full scale of a whale. It was the internal structure was steel, but the outer shell is all made out of recycled plastic. The recycled plastic we didn't count as structural because we couldn't get any structural value from it. But the internal, we made sure that can support all the forces and the loads, and that part is structural. So to that note, we can use any material that is certified to take loads, or it can take forces. And so that's for permitted projects, especially.
And certified means that a certified testing laboratory, a materials laboratory has broken it in various different ways and said, okay, this is how strong it is if I push on it. This is how strong it is if I pull on it. This is how strong it is if I bend it. And those laboratories can test almost anything. You just have to have a laboratory provide the data.
Following up on materials, do you guys get into the interactivity of materials, whether it's UV or galvanic reactions between ferrous and non-ferrous materials? How long something's going to last in the environment, or is that more the burden of the artist?
The question was about if we get involved in UV and the galvanic action between our materials. And absolutely, yes. when it comes to steel, galvanic corrosion, which just means certain types of steel, they don't actually interact well when put next to each other. So like stainless steel and carbon steel, if you put them next to each other, the electrons from one can start degrading the other. It's kind of crazy actually, but it's a thing. And so we're absolutely thinking about making sure there's like silicon barriers and